Problem 12. Two particles, each of mass m and speed u, travels in opposite directions along the parallel lines separated by a distance d. Show that the vector angular momentum of the two particle system is the same whatever be the point about which the angular momentum is taken. Okay, so here we have a two parallel lines. Okay, one this line and it is another line. Okay, so and the distance between these two parallel lines is given by small d. Okay, so the distance is d. Then two particles are travel in opposite directions along these parallel lines. Okay, two particles are traveling in opposite directions. Okay, this is one particle and it is m1, and this is another particle, it is m2. Okay, these are moving in opposite direction, means this one is moving downward direction with a velocity v1, and it is moving opposite to this one, and that is velocity is v2. Okay, so then we have to find out the angular momentum is same for the two particles. Okay, for suppose while it is moving in this direction, okay, then there is a possibility like this kind of one motion, okay, in a circular path. If we are taking this is the origin or center of the that motion. Okay, so about that center, we can calculate the angular momentum. Okay, this is our here O, the axis is passing through this point. Okay, so then first write down here what are the masses given, that is m1 is equal to m2 and that is equal to m. Okay, equal masses having the two particles. Okay, and velocities v1, magnitude of velocity, it is equal to magnitude of velocity 1 and velocity 2, and that is equal to u, that is nothing but speed of the particle, which is same for the two particles. Okay, so let us angular momentum is nothing but L is equal to r cross p. L is equal to r cross p. Okay, so now find out the momentum for individual particles. Okay, so linear momentum, linear momentum, linear momentum of m1. Okay, so that is equal to that is p1 is equal to m1 and velocity v1. Okay, so this is the velocity, and then linear momentum for m2, that is equal to p2 and it is equal to m2 v2. Okay, so this is linear momentum. Okay, so then angular momentum about O. Okay, that is angular momentum, angular momentum about O. Okay, that is center of this circle. Okay, so according to that, so one axis is passing through this. Okay, from the axis to m1, that is nothing but the distance is r1, and from the axis to m2, this is r2 is the distance. Okay, so then write down the angular momentum for L1, for m1. Okay, for m1 angular momentum, angular momentum. Okay, that is L1. Okay, vector L1 is equal to R1 cross P1. Okay, this is R1 cross P1. Okay, so direction of this R1 cross P1 is Okay, this is the r, okay, and it is our p. Okay, so whatever the direction of v and direction of p1 also same. Okay, that's why while it is moving in this direction, in this clockwise direction, for suppose, then this is r1 and it is our p1 rp, and this is outward direction, so that's why it is positive. So we can write this is equal to that is equal to r vector r cross m into v1 vector, and that is equal to r and v. This is r and v, both are perpendicular, so we can write it here. This is m1 v1 r, and that is equal to m u r. v1 is equal to nothing but u. Okay, so like that for L2. Okay, L2 about wo, that is also what, r2 vector cross p2 vector. Okay, r2 cross p2 vector. Okay, so what is the r2 here? From o, from here to here, this is r2, and this is velocity v, means p2. Okay, so p2 is also in the direction of what, v2, so that's why this is r2 and it is p2, r2, and this is p2, and this direction is outward. So in this case is also we got positive, and this is also positive. Okay, then it is equal to, this is r2. Okay, this r2 vector cross p2 is nothing but here m2 v2 vector, and that is equal to r2, and this is what, m2 v2, and this is m, and it is what, uh, u. Okay, both are same. Okay, that is from these two we can write that r1 it is the radius and r2 it is the radius of that circle, so that's why l1 is equal to l2, and that is equal to m1, sorry, mur. Okay, this is about any axis, the angular momentum vector is same for the in this case.